Thanks, team. I'm Phani Paladugu. Today I'll be covering PCI Express interface applications, implementation, and Rambus offerings. So PCI Express is used in compute-intensive applications like data centers, enterprise servers, AI, ML, and high-performance computing, NVMe storage, 5 gig infrastructure, and automotive, like especially ADAS applications. So all these applications require very high bandwidth between chips and network interfaces, and PCIe Express is really required in these type of applications to get the higher bandwidths. Before I get into further details about various PCI applications, let's look at how the PCIe standard evolved over a period of time. So back in 2003, PCI SIG rolled out Gen 1 specification, and each lane is operating at 2.5 gigabits per second. Then after that, Gen 2, Gen 3, and today we are at Gen 5 speeds, where each lane is operating at 32 gigabits per second. And by 2021, PCI SIG is planning to roll out the PCI Gen 6. At that speed, like it is running at 64 gigabits per second. So if you look at the table, Gen 4, each lane will be running at 16 gigabits per second. With that speeds, we'll be able to achieve 64 gigabytes per second full duplex aggregate bandwidth. If anyone is looking for more bandwidth than 64 gigabytes per second, we have to use PCI Gen 5, and each lane will be running at 32 gigabits per second, and the overall throughput can be up to 128 gigabytes per second. So let's look at the PCIe applications in especially data center networking, compute storage applications. PCIe is used to connect NIC or smart NIC from top of rack switch to the CPU. On the other side, the CPUs can be connected to GPU or AI accelerators using a PCIe. Uh, PCIe is used to connect the NVMe storage devices to CPU. And also host bus adapter uses a PCIe to connect the CPU to external storage and hard drives. Let's get into further details. In today's NIC or smart NIC applications, most of the PCIe is like a Gen 4 by 8. In future hardware, wherein we'll be using a 200 gigabit Ethernet or 400 gigabit Ethernet applications, we need PCIe 5 by 8 macro and PCIe 5 by 16. In today's accelerators, PCIe is PCIe Gen 4 by 8 macro. In future, for AI, ML, and high performance computing, we need at least like by 16 macro operating at Gen 5 speeds. In storage, currently we are using PCIe Gen 4 by 4 macro, and in future we need to move to PCIe Gen 5 by 4 macro. Rambus offers various PCIe files in different process nodes and across foundries. And we do offer a controller. Controller is a soft macro. It is process agnostic. So our files are in production with 50 plus customers up to Gen 4 speeds and lower speeds. Our PCIe 5 is available in TSMC 28 nanometer, Samsung 14, and Global Foundries 12 nanometer. In these three nodes, our 5 is silicon proven and in production with multiple customers. And we taped out our Gen 4 5 in 22 FDX. And we do offer PCIe Gen 5 and CXL 5 in 7 nanometer. We have the silicon back in lab, and we are working with few lead customers. Rambus offers a fully integrated and pre-verified PCIe Express solution, wherein our team integrates PHY and controller together and deliver it as a subsystem to our customers. In this delivery, the PMA is a hardened macro, PCS and controller are soft macros. So we do offer the end-to-end complete solution. We offer PHY, controller, and for high performance applications, the customers needs the DMA as well. We do offer the DMA. And most of our test chips are taped out with a multi-lane PHY and controller together. We are the only IP vendor out in the market who tapes out the controller along with our PHY in a test chip. I would like to highlight Rambus PCIe 5 and CXL5 advantages. Our 5 has a best-in-class power, performance, and area, and we do offer a fully integrated and co-validated 5 and controller subsystem. So that way we can save a lot of effort on for our customers. Multiple designs are in production with customers across different process nodes. And our team has very good system level expertise, and we will be able to help our customers during a signal integrity, power integrity, package, and board designs. So our PHY has a very rich DFT and debug features like multiple loopback modes, non-destructive eye monitor, and various PRBS generators and checkers are implemented within the IP. That all these features will help our customers during a bring up and a debug phase. So in addition to this, our files are optimized for L1.2 standby power and L1.2 to L0 exit latency. Some of the power sensitive applications, PCIe link will be moved between the active mode and the low power mode. So this particular mode will help us, our customers, to save power during the low power modes. That's all I have for today. I'll be turning it over to my colleague Vinitha.
Thank you, Phani. My name is Vinitha, and I will be focusing on the Rambus controller solutions. So Rambus provides a very comprehensive solution for PCI Express, including cores and drivers. We've been supporting PCI Express since 2006, formerly Northwest Logic. Northwest Logic got acquired by Rambus last year in 2019. We provide a very high performance solution that supports all of the available PCI Express SerDes rates from PCI Express Gen 5 all the way down to PCI Express Gen 1. We provide a complete solution where we do not only provide the PCI Express base controller, but we also provide a very high performance SCADA gather, DMA, and driver support. And the solution is fully validated with the target PHY. In addition to that, we also do provide FPGA support as well. Our solution is very configurable, so therefore it maximizes the performance and minimizes the size. We've had great success where we've had first-time silicon success on all tapeouts. And since our IP is soft, it is foundry and process independent, so it can be used on any foundry and process nodes. The solution is proven and been used by a variety of customers in a wide variety of applications, including military, medical, storage, communications, and broadcast applications. So let's take a closer look at our controller solution offering. It consists of the controller core and also the DMA core. The PCI Express controller core is a very flexible, high performance, easy to use transaction layer interface to the PCI Express bus. Some of the features are as follows. It is PCI Express Rev 5 compliant, and it is PCI Express also backward compliant to 4, 3, 2, and 1. It supports by 16 all the way down to by 1 lane. And it supports all of the SerDes rates, where 32 gigabit per second SerDes rates is the PCI Express Gen 5 solution. We also provide a very comprehensive application support, which includes endpoint, root port, endpoint/root port, dual mode support, switch, and verification. And for most customers, a full transaction layer meets most of their needs. However, for customers needing transaction layer bypass or partial transaction layer options, we also do offer that as part of our solution. And the core also supports SRIOV multifunction operation as well. Now, the controller core is very rich in features, and I would encourage you to reach out to us and get access to our data sheet so you can take a look at the full list. The PCI Express controller core is delivered with the PCIe test bench as part of the deliverables. Now, Rambus also provides a high performance DMA axis bridging support as well, which further extends the PCI controller core's functionality. And we'll take a closer look at it on the next slide. So why do you need a DMA core? If you're trying to maximize the PCI Express bandwidth, you do need a DMA operation for that. The throughput that you get through CPU reads and writes is not going to be adequate. And Rambus provides a very high performance scatter-gather based DMA core. And as you can see on the screen, we provide 3 flavors of our DMA cores. Some of them are useful for our FPGA implementation and the other for our ASIC. The Espresso DMA Bridge core is the superior of all of the DMA cores that we offer. And in addition to it providing a very high bandwidth DMA, it also provides a very high bandwidth axis bridging support as well. It supports memory mapped and streaming DMA operation, supports large number of DMA channels, up to 1024 channels, and it also provides support for multifunction SRIOV operation as well. Now, we also do offer DMA drivers that are companion to the DMA cores, and we support both Windows and Linux operating systems as part of our drivers. And the drivers also come with a command line interface for testing purposes. The DMA cores are meant to be used with the Rambus PCI Express soft cores. In addition, you can also use the DMA cores with an FPGA-based hardened PCI Express IP as well. Let us take a look at our validation effort. We comprehensively verify our IP. As part of the simulation-based verification, we use the Rambus PCIe test bench as part of the simulation-based verification. In addition to that, we also utilize a third-party VIP with compliance suite as well. And we use the Avery Design System PCI X Factor VIP. It goes through hardware-based validation, where we perform testing across a wide variety of motherboard and plug-in FPGA cards. It goes through PCI SIG certification, where we have periodically taken our course for PCI SIG certification at the PCI SIG workshops. And it is fully silicon proven, where we offer controller plus PHY test chips. We do controller plus PHY test chips. And in addition to that, it's also widely used in a large number of customer designs for both ASICs and FPGAs. So looking at our PCI Express support on the PHY side, as you have heard Phani mention, that we do provide PHY solutions as well. So you can come and get the controller plus the PHY offerings from Rambus. But in the case where you would want to use our controller with a third-party PHY, you do have that option as well, where you will license a PHY from the third-party PHY vendor, and you would come to us and we would take ownership of the controller fully integrated with the customer specific PHY for an integration fee. Rambus also provides a controller immediately with the Rambus behavioral model as well. And this delivery is useful because it simulates very fast, and also it enables the customer to start the design development prior to the actual PHY being available. And since we take ownership of the controller and the controller plus PHY integration, we will work closely with the PHY vendor to ensure all of your questions are addressed and addressed quickly. So to summarize the controller portion of the presentation, we provide a very full solution for your ASIC designs where you can get the controller and the PHY, and we provide a very high performance solution where it's a proven high performance solution across a broad range of applications. It is fully silicon validated, where we have 65 plus ASIC and over 800 plus FPGA design wins, including DMA licenses. All tapeouts are first time silicon successful. And it has been PCI SIG compliance tested. We provide a comprehensive solution where we not only provide the PCIe base cores, but we provide a scattergather based DMA engines and bridging support along with drivers. We support all of the flavors of PCI Express from Gen 5 to Gen 1. And we support all of the we provide comprehensive application support, such as for root port, endpoint, dual mode, switch, and verification, including ECNs. And our solution is easy to use. We provide a complete prepackaged solution, including DMAs. We provide it with a test bench, including behavioral and target PHY models, and it is optimized for ASICs and FPGAs. And lastly, we provide the core fully configured per the customer needs and integrated with the PHY along with the complete reference design for out-of-the-box use. And you get direct support from the core designers. And the solution is, we do offer customization and integration services as well. So I would encourage you to reach out to us and get more additional information on our offering. And we hope to be able to support you on your next PCI Express based design needs. Thank you.